the basic concepts in seismology were proposed many years ago. And since then these concepts have roamed from study to study for many years. So what fundamental concepts will be put into artificial intelligence so that artificial intelligence can help seismology to reliably predict earthquakes? Perhaps, at first, the artificial intelligence will explain that there are no special laws that are created specifically for seismology. At the same time, even philosophers, who were at the origins of natural philosophy, would confirm that there are certain laws common to all natural systems in nature and it is simply necessary to take this into account. An earthquake is the process of releasing tectonic stress in the Earth's crust. This process is also governed by the laws of nature. Stress in the crust can be released in a variety of ways, from earthquakes and creep to the slow rising and falling of sections of the crust. From all of these options, nature selects the one that will release the most energy while expending the least energy. Any natural system behaves the same way. A river covers the maximum area while minimizing its length and its energy expended, just as the circulatory system in a living organism serves the largest possible area with the shortest total length and least possible energy expenditure. The veins in a leaf follow the same principles. This is why we often see so-called false precursors of earthquakes. The predictive signs are all there, but there is no earthquake. In this case, the predictive signs speak to the system's overall condition, and where the system chooses to release its stress depends on the advantageousness of energy expenditure. In this regard, the accumulating stress behaves within the framework of the Fermat principle. The movement of a light beam, moving from one point to another, the light always chooses the path that requires the least time to travel the path. And of course, it is extremely difficult to predict the behavior of a system that, from a multitude of options, always chooses the one that minimizes energy expenditures. In order to predict events, one must know the system's current energy advantage, where it would be most advantageous for the system to release its energy. Only this enables one to make a precise prediction. The same holds true for other areas in seismology. For example, a large number of geological factors are cited to explain why earthquakes tend to be grouped in time and space. The assumption is, in part, that groupings may be caused by a trigger effect, whereby an earthquake in one location triggers a new release of energy in neighboring areas where tectonic stress has built up. This process, in different variations, has been researched for over 100 years. This may very well be the case, but the grouping of events and objects in time and space is a normal, general law of nature. Even the distribution of, say, red cars in a large parking lot will be absolutely identical to the grouping of earthquakes in space and time. Nature uses grouping whenever it can, and it's easy to explain why. If we arrange events or objects in a space divided into equal parts evenly without grouping, then we only have one option. All the events or objects are evenly distributed, with one event per cell. If the system were to use this distribution, it would require a tremendous amount of energy to keep one event per cell, and to keep the system from collapsing. But in the case of the characteristic grouping usually observed in nature, the options for distributing objects in space are almost infinite. The statistical distribution is absolutely identical for any of the options. The system doesn't even notice when something is added or taken away, because the overall distribution remains unchanged. There is no need to spend excess energy supporting a strictly even distribution. In the same way, a healthy heart does not beat evenly like a watch. Doing so would require the body to spend too much energy on regulation, for example, after sudden exercise. It is more advantageous for the body to allow the heart to beat in a regular arrhythmia. This arrhythmia can be described mathematically as a grouping in space and time. All events in nature obey certain laws that apply to many systems, and this must be taken into account when studying seismic events. Thus, Inaccurate representations can be conveyed to artificial intelligence as basic and truthful. And this is regardless of the consequences that a person unknowingly, or consciously, provokes in the future. Therefore, teaching artificial intelligence the right knowledge has another very important mission. When a person begins to teach artificial intelligence just the general laws of nature, then a person will be able to learn the right things from artificial intelligence itself.